We often think of science as just finding facts, but really it's about the journey to find answers. Today, we're going to follow one of those journeys. It's a high-stakes medical investigation that shows us not just what happens to our bodies under extreme stress, but also how scientists can see the full story, a story that unfolds over time. Okay, let's jump right in.
Just try to imagine for a second the intense, incredible stress of open-heart surgery. It's got to be one of the most demanding things the human body can possibly go through. And researchers, they wanted to understand a very specific and kind of puzzling reaction that happens right there in the operating room.
So, the massive physical trauma of an operation like a coronary artery bypass, they call it CABG for short, it sends your body's stress response into absolute overdrive. And what happens? It triggers this huge spike in blood sugar, a condition called hyperglycemia. It is so common and so dramatic, they actually have a name for it: surgical diabetes.
Okay, now here is where it gets really interesting. This is the core puzzle. You totally expect a diabetic patient's blood sugar to spike, right? But this surgical diabetes happens to non-diabetic patients too. It's like the extreme stress of the surgery itself is such a powerful force that it just levels the playing field, making a non-diabetic person's body react in a way that looks, well, a whole lot like a diabetic's.
So you can see how this sets up a really fascinating question for scientists. If both groups get this massive blood sugar spike from the stress, is their body's journey through that experience actually the same? To figure that out, they needed to set up a direct head-to-head comparison.
So what they did was they got two groups of 30 patients, and they were all having the same heart surgery. Group 1 had well-controlled insulin-dependent diabetes. Group 2, no history of diabetes at all. And you can see they were super careful to match them. The ages are nearly identical. They wanted to make sure that the only real difference between these two groups was their diabetic status.
And this right here, this is the heart of the whole study. The researchers weren't just asking, hey, is their blood sugar different at the end? No. They were asking something way more sophisticated. They wanted to know, is the trend, the actual pattern of how their blood sugar changes from the beginning, through the middle, to the end, is that pattern the same for both groups?
To answer a question about a trend, about a pattern, you can't just take a single snapshot, right? You need to roll the camera and capture the whole movie. And that requires a very specific scientific method, one that's designed for tracking change over time.
And here's exactly how they did it. For every single patient in both groups, they took blood samples at 3 key moments. First, they got a baseline right before anesthesia kicked in. Second, they took a bunch of samples during the bypass. That's when a machine is literally doing the work of the heart and lungs. And then they averaged those out. And third, a final sample right after the bypass was finished. This repeated measure strategy gave them a clear timeline, a little movie for every single person.
So, the challenge is pretty clear. You have 60 individual journeys, 30 from the diabetic group, 30 from the non-diabetic group. You can't just compare the starting points or the finish lines. You need a special kind of tool that can look at the entire shape of that curve and compare the journeys themselves.
And this is the hero of our story. It's a statistical tool called Repeated Measures ANOVA, or just ANOVA for short. Its whole purpose in life is to do exactly this. It's designed to look at data from the same people, collected over time, and figure out if the pattern of change is actually different between groups. It's the perfect tool for the job.
Let's just quickly break down how it works. Think of it like a recipe. First, you start with your distinct groups, diabetic versus non-diabetic. Check. Then you measure the same variable in everyone, in this case, blood glucose. Check. Third, you repeat those measurements at your specific time points. Check. And then, this is where the magic happens. ANOVA analyzes those trends and tells you, with statistical confidence, whether the journeys of those two groups were truly different or if they were surprisingly similar.
Okay, so the stage is set. The researchers had their two carefully matched groups, they had their timeline of data, and they had their powerful statistical tool ready to go. They crunched the numbers, and what they found was, well, probably not what you'd expect.
And there it is, the key finding, pulled right out of the research paper. Despite one group having diabetes and the other not, the pattern of how their blood sugar changed during the surgery was statistically indistinguishable. Their journeys were the same.
If you're not a stats whiz, don't worry. A p-value is just a score. A really, really low score, usually anything under 0.05, means, yep, these are definitely different. Well, the p-value they got here was 0.59. That's not just a little bit over 0.05, it's miles away. It's basically the statistical equivalent of a giant flashing sign that says, nope, nothing to see here. These trends are the same.
And this is what makes it such a great piece of research. They didn't just look at glucose. They tracked a whole panel of other important things in the blood: lactate, pH, a bunch of electrolytes. And guess what? For almost all of them, the RME ANOVA told them the exact same story. No significant difference in the trend of change between the two groups.
Now, in the spirit of full disclosure, there was one tiny exception. The trend for something called PaCO2, which measures carbon dioxide in the blood, was statistically different. But, and this is a big but, the researchers pointed out that the actual difference was so incredibly small that it had no real-world clinical importance. It didn't change the big picture at all.
So let's step back for a second. What does all this mean? The results are really fascinating for sure, but the bigger story here is about how we find the truth and why picking the right tool for the job is absolutely everything.
The scientific conclusion is pretty powerful. The stress from this kind of surgery is so profound, so overwhelming that it essentially overrides the patient's underlying condition. And for doctors, that's huge. It means that during these procedures, they need to treat every single patient as if they're at risk for these major blood sugar swings. They have to watch everyone like a hawk, not just the patients who came in with a diabetes diagnosis.
And this is the whole point, the reason we're even talking about this study. Just think about it for a second. If the researchers had only measured blood sugar once at the very end of the surgery, they would have completely missed the story. It was using the right tool, that repeated measures ANOVA, that allowed them to see the entire movie, not just the final frame. The method was the key that unlocked the discovery.
And that leaves us with a bigger question, doesn't it? Something to think about in all parts of our lives. Whether we're looking at medical results, or the stock market, or even just our own progress on a project, this study is a great reminder to ask, are we just looking at a single snapshot, or are we seeing the whole journey? Because sometimes the real story isn't in the destination, but in the path we took to get there.